right, let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1000. Hopefully you guys are doing okay. Let's actually jump into it. It's the last, well, probably, I don't know what's gonna happen for the rest of this week, but it's our last live lecture for the semester. Okay, so let me make sure that I can see the chat. And again, just to make sure you guys are participating, please have your video on if at all possible. Don't be afraid to participate. We don't really have a lot planned for today. Just want to lay out the next week and take any questions that you guys might have. So yeah, that's basically it. So in terms of material, we have covered everything. Or is there a lecture that you guys have to watch today? I don't remember. I don't think so. But either way, today would be the last day of material. If not, it was last week. Let me make sure. Because this semester, with all that's going on, it seems that students are rarely up to date here. Right, so the last lecture is scheduled for today, so you should be watching lecture 25 today. But hopefully you watched that before. It would have really helped you on for the bonus problems on the second test. Speaking of the second test, I expect to have the grades for you guys soon. So that's currently being graded. So far, the average seems pretty close to what the first test was. So it seems very similar. So I don't know. Not much improvement so far, if any. But I mean, it wasn't bad the first test. So, but yeah, so far that's how things are looking. So I just also want to mention that the deadline for the homework is December 9th. So be aware of that. The final exam date and time, do not miss it. This is on Monday, December 14th at 9:30 a.m. In terms of the format on the final, you would be given around 25 problems. So normally your quizzes are around 20 problems, and then I give you a few bonuses. So the final will have 25 problems, all compulsory. And I will actually, in this case, ask you to show your work for the majority of the problems. So somewhere 20-ish problems or so, maybe even a little slightly a little bit more. I might ask you to actually show work for all those problems. That being said, the final is going to last, I guess I can mention it here. Length is 2 hours and hard to type on this tablet. 2 hours and 15 minutes. And that 15 minutes is for upload. Okay. The topics, pretty much everything. But off the top of my head, the things that are sort of important for you to know are the following. Yes, the final will be on Gradescope. Let me also make that clear. Thank you for your question. It will be on Gradescope as usual. I would say you can expect to be a combination of test 1 and test 2 type problems. Okay, yeah. So by way of update, so you should be watching the last lecture today. That's lecture 25. That will cover trig with addition formulas and solving trig equations, which was asked in the bonus of the last test. The last test, I'll finish with that in a day or two, and I'll publish your grades. Last day for homework is midnight on December 9th. And the final exam date is that date. In terms of the final, it'll be 25 problems. You have to do everything, and you will have to show your work for the majority of them. That being said, I don't think, usually for tests, I ask you to show your work for half or less, so like 10 problems or less. But for the final, I'm going to ask you to show your work for the majority of it. And I think this is still pretty fair, because normally I give you a test and it's 20 problems, and I give you an hour and 15 minutes. So if I give you 2 hours and 15 minutes for 5 extra problems, you should have more time to actually upload more work. So you're having almost double the time with almost the same number of questions. So by that regard, I don't think you're going to run out of time. If you haven't been running out of time on the regular test, you shouldn't run out of time on the final. But yeah, you are going to have to prove that you can write out and explain yourself the majority of the time. It'll be on Gradescope as usual, and you can kind of expect something like a combination of test 1 and test 2. So you already know the types of questions I would ask. It's pretty much going to be the same kinds of questions. Pretty much the final is cumulative. So the topics is everything. Off the top of my head, some of the things I wanted to mention, some of the themes that have been coming up. You need to know everything about functions and their representations. So that I give you a function as a graph, or a mapping diagram, or a table of values, or a set of coordinates. You should recognize it's a function, know how to deal with it. Recognize piecewise functions. Of course, you know how to simplify functions, know how to evaluate functions, know how to do operations with functions, like composing them, plugging one function into another, know how to find inverse functions, how to graph functions, how to graph their inverse functions. And functions here, I mean it in the general sense in terms of all the functions that we've covered. So we're talking about polynomials, log functions, exponential functions, trig functions, inverse trig functions. So pretty much know everything with functions. Remember how to simplify expressions in general. So if I give you a rational expression, you should know that, oh, I should try to factor the top and bottom and cancel common factors. Or if I give you like an expression that mixes exponentials and logs, you should know how to maneuver things so that the exponentials cancel the logs or vice versa, and simplify expressions of that sort. Know about circles, distance formulas, midpoint formulas, laws of exponents, laws of logarithms, solving all sorts of equations and inequalities. So this includes polynomial equations, equations with rational expressions, equations with radical expressions, trig equations, exponential equations, log equations, pretty much equations involving any of the functions that we looked at. You should know how to solve them. Know how to sketch graphs, know how to identify graphs. So if I give you the picture of a graph, you should be able to pick out the formula, and vice versa. If I give you a formula, you should be able to choose from a set of graphs which graph matches that formula. talk about the features of a graph, like what's its end behavior, what are some coordinates it goes through, things of that sort. Know everything about trigonometry, know everything about factoring. Factoring is very important for solving equations. Know about long division. We had a couple questions on long division in the last test as well. Know about the rational roots theorem, the factor theorem, knowing how you can use long division to help you factor something. Know how to compute the difference quotient. That's important. You're going to see that again in Calc 1. So yeah, these are just some of the things off the top of my head. So don't think of this as being exhaustive. Pretty much know everything from this from the entire semester, but I just thought I'd throw some things out there in case you guys forgot what we covered. So that is basically it. Now, in terms of in terms of what else we wanted to cover today, there are a couple things that I think we could do. As you know, I gave you the solutions to test 2 already. That was posted on Piazza. So if there are any questions on anything from test 2, I can take those questions now in preparation for the final. Or if there are any other questions about the final specifically, then I can take those as well. Maybe you might want to ask me a different problem type that you were concerned about. So at this point, I think we can move on to that. No. Q&A. It's hard to type on this keyboard. Does this work? Okay, yes. Let's make this big boo. Okay, so Q&A, like I said, a couple things you can ask me about. You can ask me about test 2, anything that you're really sure about, that you want to know about, because of course, test 2 material is going to be relevant for the final because the final is cumulative, as well as ask me any other questions on the final in general. Okay. Correct. And I was going to send out an email about that. So I'm going to do that anyway. But I already mentioned this a couple times, but I still get that question a lot. So I'm going to send out a mass email about it again. So just for the record, bonus points cannot hurt you. They can only help you. So I know some people were concerned that if they didn't do the bonus points, they thought they lost points because on Gradescope, the total was bigger than da-da-da-da. And the thing is, remember, on Gradescope, I put the bonus points in the total to make sure that I count them towards your real grade and I don't miss them. However, your real grade is on Jupyter grades. So Gradescope is not where you should be looking for your real grades. Gradescope is where you can review the test, you can see what you got right or you got wrong, but your actual grade is on Jupyter grades. And when I put it on Jupyter grades, the total changes, right? So I don't count the bonuses in the total, but they do count as the number of points you got out of the total. So the bonus points are extra. So if you don't do the bonus, it can't hurt you. It can only help you. So doing the bonus means you give yourself the potential of getting over 100%. If you don't do the bonus, it just means the maximum you could get is 100%. But 100% is still everything. 100% is still A+. So the bonus is just giving you an extra incentive. Think of it as extra credit. So it can't hurt you no matter what. So if you think the bonus points can hurt you, it will not. It will never hurt you. Do not look at Gradescope for your grades. Look at Jupyter grades for your grades. I have to count the total in Gradescope differently because I don't want to miss anything. So if I didn't let the bonus points count in Gradescope, then I would have to manually go in and see how many bonus points each person got, and then I'd have to count them up on my fingers and then enter it into the grade. And that's just, there's too much ways that error could crop in there. So yeah, so Gradescope, I do count your grade differently in Gradescope, but once I transfer it over, I transfer it to Jupyter grades in such a way that the bonus points will not hurt you. Gradescope is not where you get your grades. What else did I want to say in terms of grades? Because there are a couple of things questions that I kept getting asked, even though I mentioned it. And I'm still going to send this out in writing because I feel like my other class, I get questions from my other classes as well. Yes, on Jupyter, when you're concerned with should you look at the numerical grade or the letter grade, because they don't really coincide with the GPA table that I gave you in the syllabus. So what you should be aware is I already have a curve built in into the grading. So there are times when your numerical grade is actually lower than your letter grade, and that is actually on purpose. So I said, for example, A minus is in the GPA chart in our syllabus, A minus starts at a 90. I think so this is just for example, the class is curved so that A minus actually starts at an 85. So if you have a score of an 85, and you see an A minus, and you're wondering, oh, is Jhevon going to give me a B plus or an A minus? Well, I would give you the A minus. So I want to make sure, and this is something else I'm going to put in writing, because a lot of times students just think their professors are trying to get them to fail or just being extra mean or something like that. So I put a lot of cushion in there to kind of protect you guys. So pretty much I do a lot of things where it's like you will get the grade you deserve or better. You're never going to get a worse grade than you deserve. Like even if I grade too harshly, I put in a cushion that it bumps you up. So it's like, yeah, you're going to get the grade you deserve or better. So it's not like you're not going to lose out in any way, shape, or form. I actually give you guys the benefit of the doubt in so many ways. And so that explains the discrepancy between the letter grade and the numerical grade in Jupyter. When you look at your grade in Jupyter, the higher grade is the one you're going to count because that's the one I curved, and the higher grade is going to be your letter grade. So the letter grade is what you're getting. And it has a curve built in. So pretty much it ensures that you will get that grade. That grade will be either the grade you deserve or higher, depending on where in the ladder you fit in the curve. So that's also was something that I got questions about. What else did I get questions about grades? I don't remember right now off the top of my head, but I started writing out an email compiling all these questions I got about grades, and I'm gonna send something out like that to cover that as well. So how do our grades work? Answered, and we'll send email. Okay, second question. Will the answer key for test 1 be posted on Piazza? No. So solutions for test 1. This will not be posted on Piazza. I was gonna write pizza. I actually haven't had breakfast this morning, so I'm pretty hungry. Piazza will not be posted on Piazza because I actually did those solutions with you guys. We went through those solutions in class. So there is some class notes where you will have those solutions. So you already have the solutions in class notes. I did not do the solutions for test 2 with you in class, which is why I posted on Piazza. Test 2 solutions are on Piazza. So I explained everything, even the problems where you didn't have to show work. I did a little bit of explanations for them so you can actually see where the answers are coming from. But if of course, if you had questions, since you weren't there to ask questions in person, you can let me know. You can let me know on Piazza, right? Just so you can post a follow-up to that, to the post of the solutions and say, hey, in solution for problem blah, I don't understand why this happened or whatever. Since we did not do that in class. So that's solutions for test 1. You can ask questions in Piazza regarding, I'm actually write out regarding solutions you don't understand. By making follow-up posts. And I would definitely recommend that you do that as opposed to, because as I mentioned, this would be much more efficient. Do not personally email me about this. So from now on, personal emails should be regarding your personal situation. So if there's something other than the material for the class that you need to ask me about, then yeah, shoot me a personal email. If you want to ask me anything about the class, you want to ask me about a math problem, you want to ask me about the solutions to a certain problem in a test that you didn't get, anything that has to do with the math, post it on Piazza. That way I can answer it once and answer it for everyone at the same time. And it's beneficial for everyone involved. It saves me time, and it also gives everyone an answer to a question that they might not even know that they needed the answer to. And so that will be very useful. You can post anonymously, although really it doesn't matter. I like to see that you ask questions. So if I can see your names, that will also be good. Some bonus points there, brownie points. But of course, if you're ashamed, you think you're asking a silly question, which if you attended my study hall sessions, I explained to you why that should not be a concern of yours ever. Yeah, so you want to post questions. Yes, partial credit will be available on the final for all the problems that I asked you to show work for, which, as I mentioned earlier, I will ask you to show work for more problems, the majority of problems. So you will be able to get a larger percentage of partial credit than you would have gotten on an ordinary test. So on an ordinary test, You could only get partial credit for like half the problems. And the other ones was just, you're right or wrong. But for the final, for the most of the problems, you're going to be able to get partial credit for. And the few remaining problems are the problems where, in my estimation, they're so easy to the point where if you don't know it, then it's not even warrant giving you partial credit for. But yeah, like I said, on the final, the majority of the problems will be problems that you have to show your work for, and I will be giving you partial credit based on this. So yes, thank you for your question. Any other questions, concerns, comments?
I actually have a question about a problem on test 2, if we could go over it.
Sure. From test 2?
Yep.
Yeah?
It is question 5, and it's find sine A plus B.
Oh, hold on.
Oh, okay, sorry.
No, wait, just give me a second here. So you said it's question 5.
Yep.
So what I'm doing, I want to take a screenshot of it so I make sure that I'm not missing anything. So this is Q5. Yeah? This one, sine of A plus B?
Yep.
Okay, yeah.
So when I was looking at the solutions, I was wondering like how you got
So,
like
let me make sure to just go over this in general.
okay.
So what you would want to do is, first of all, so first, you should know what is sine of A plus B, right? So sine of A plus B equals sine A cosine B plus sine B cosine A, right?
Yes.
So that's just a form you should know. Then you should realize that sine of A is given. And then you should realize cosine of B is also given, which means this one, we don't know what that is. And this one, we don't know what that is. So in the solutions, you'll notice I started out by trying to use SOHCAHTOA to figure out sine of B and cosine of A. And so why I started that is because I knew in my head, oh, I'm going to need these guys eventually. So that's when I wanted to find those. So now I went and I tried to find it. So how do I find cosine of A? Well, I know that if my sine of A is minus 1/2, what I do is I can construct a triangle based on this, ignoring the negatives for now. So we know that A is in quadrant 3, I believe they told us. Third quadrant, yeah. So sine I know is opposite over hypotenuse. So this would be opposite hypotenuse, which means that by Pythagoras' theorem, this is going to be the square root of 2 squared minus 1 squared. And so from this, I can find the cosine of A. That's going to be adjacent over hypotenuse. So that's going to be radical 3 over 2. And then, again, I put the negative sign in there because I know we're in Q3 and the cosine is negative there. Because A is in Q3, so cosine A is negative.
I have a quick question. I think this is where I got a little confused. I was
Okay.
wondering if cosine A and I mean sine A and cosine B, were they on different triangles? Because the
Yeah, they'd
hypotenuse.
have to be different triangles. So
Okay.
now if I look for the sine of B, I mean, what information do I have? Well, for B, I know the cosine. I know that the cosine of B is minus a third, right? Which is not the same as the cosine of the last one. So this is clearly a different triangle. So it's not a theta here. What I have here is the A specifically. And from this one, I have the B specifically. Cosine is adjacent over hypotenuse. So this is going to be radical 8 because it's the square root of 3 squared minus 1 squared. And so this would mean that my sine of B is going to be opposite over hypotenuse. But again, I choose a negative because we're in Q3. And so now we know all the values. So now I just plug them in. Now we know all the values for our formula. So then I know that my sine of A plus B is equal to sine A cosine B plus sine B cosine A. And I know that sine A was minus a half. Cosine B was minus a third. I know now that sine of B is minus square root 8 over 3. And I know that cosine of A is minus rad 3 over 2. So this gives us 1 over 6 plus radical 3 radical 8 over 6. Radical 8 I can simplify. So this is radical 3 times 2 rad 2 all over 6. So then you just get 1 plus 2 rad 6 over 6. And so that's why that was the answer.
Okay, thank you.
So did you get that? Did that clear it up?
Yeah, it made more sense now. I think I messed up because I was.
Yeah, so the A and B were from different triangles. They were from different angles.
Okay.
And another way you would know this is from that table that I had you guys memorize for the special angles. You should realize that whenever sine has magnitude of a half, the corresponding cosine is going to have a magnitude of radical 3 over 2. So the fact that the cosine here didn't have radical 3 over 2 magnitude kind of tells you that, oh, it had to come from a different angle altogether, which means I'm looking at a different triangle. So yeah, there were 2 triangles involved. Other questions? And I guess you don't really have to write this up unless you have an epiphany and you want to write down the thought right now, because I wrote up all the solutions. However, in the solutions, I did these 2 first, and then I applied this. But I did those 2 first because I remember the formula, so I know I was going to need them eventually.
I actually have another question about
Yeah.
question 19. When I was looking at the solution, I was a little confused.
Q19.
Yeah, I was just a little confused.
Hold on, let me paste it. Q9. 15. Yeah, that was an interesting one. Yes. Okay.
When I was looking at the solution, I saw a common error was pointed out, and I was just a little confused on how the x must be 3. So like how it was a division by 0.
Oh, so one thing you should have noticed is that this was 3, and so we know it does not have an inverse. But suppose we didn't notice this. Right? So we would do what? We would switch x and y and solve for y. Right? Now, if you did that, you would have x equals 3y minus 6 over y minus 2. You would cross multiply, so you get xy minus 2x equals 3y minus 6. And you can immediately see here that your x must be equal to 3. Also here, to get a 6, your x must be equal to 3. So we know right here, so x equals 3, right? That's the only way that this equation is going to be true. And so there comes a point, so if you were continuing, you would have moved the y's to one side. You would factor out a common y. And then you would divide by this. But because the x is 3, this is invalid. But that one was tricky, I will admit. So if someone did the work and got this, I believe I gave them 3 out of the 5 points. Yeah. So the 2 points is for the extra A plus student who kind of realized, hey, something's fishy is going on here. And if they could figure out what that thing was, then they would get all 5 points. But because this is what I trained you guys to do, if you mindlessly jump into this and actually execute it correctly, I would give you 3 points out of the 5. But it's actually not the correct thing to do because it's a division by 0.
Okay, thank you.
Other questions? Yeah, so just to reiterate, your homework is due on Wednesday. So I believe last day of classes is tomorrow. So Wednesday you should be free. I think Wednesday and Thursday everyone should be free because finals week actually starts on Friday. I want to say that's when finals week starts. And then Yeah, so our final is Monday. So that's like a week from today. A week from today to make sure that you learned from your mistakes on test 1 and test 2 and you come back strong in the final. So a very strong final will go a lot to improving your grade, even beyond what is fair. As you guys already know, I'm already giving you guys a grade that's better than what the official GPA chart says I should be giving you. The final is going to be 25 problems. There are no bonus problems on the final because there's no extra credit really. It's just everything. You should know everything. There's no reading ahead anymore. So 25 problems. You're going to show your work for the majority of them. You're going to have pretty much double the time that you would normally. Yeah, you should be able to get everything done. Topics cover everything. Yeah, solutions for test 1. I already actually went through that with you guys, so that is in a class notes somewhere. I forgot what lecture it was in, but I definitely did that already. Solutions for test 2 are on Piazza, and moving forward, if you have any math questions specifically, ask them on Piazza. So that would be more efficient and helpful for everyone involved. And then we answered some questions on test 2. The final is going to look very similar to test 1 and test 2. So whatever kind of problem types show up in test 1 and test 2, that's what you should be prepared for. So it wasn't all multiple choice. Sometimes there were fill in the blanks. Sometimes there were select all that apply, etc. Did I put that up here? Yeah, test 1 and test 2 type problems. Any other questions? I have about 25 minutes left, so no rush. 25.
I actually have another question about the first problem. It's kind of like a general question about
Mm-hmm.
question 2. Just speaking about like the period. Um, so when looking at a graph, does a period fulfill like when a graph, like I thought it was when it went like up and down and then back up to the x-axis, or is it just after one reaching the amplitude and coming back down to the x-axis?
Well, technically, the period is the length you have to travel before you start repeating a behavior. So a lot of times we do this in terms of a standard graph. So there's a certain point on the graph that we like looking at. But it doesn't always have to do that. So for example, more on period. So period equals horizontal length before we repeat a pattern. So what does that mean? Let's say here, so you'd pick a spot. where you know what's going on in that spot, then measure how long before the behavior at that spot repeats. So for example, let's say I'm using the standard sine function, for example. So a lot of times what we did was for the standard period, we pick here. Wait. Let me actually copy this because I want to illustrate an idea on the same picture. Just in case it's not a standard graph, you can see the idea. So for example, what we like to do is we like to pick here. And then you realize that, okay, what's happening there? Well, it's going up into the origin and leaving the origin. So it's moving as I go up from left to right. So what I do is I just continue running along this graph until that same behavior repeats. Boom. When I reach here, I realize what I'm doing. I'm going up through the x-axis from left to right. So right here, you realize behavior repeats. And so now, if you look at that length, what would have happened was you would have gone through 2 pi. Right, so here is say pi over 2, here is pi, here is 3 pi over 2, here is 2 pi. So if I measured that length, you'd realize that it takes me a distance of 2 pi horizontally before whatever I was doing at my reference point starts happening again. But there's nothing special about that point. So I might give you a graph as an example where I don't connect the graph to the origin. But there's nothing special about picking the origin. So we could pick where angle is pi over 2, say. Okay, so again, this is the regular sine function, so that's pi over 2. This is going to be pi. This is going to be 3 pi over 2. This is going to be 2 pi. This is going to be 7 pi over 2. So 3 pi over 2, 4 pi over 2, oh no, 5 pi over 2. What am I doing? So let's say instead of picking at the origin, I started here. So it's the same graph, but someone picks a different point. What am I doing? I realize that I'm at the peak, I'm going and I'm leaving the peak going down. So through that point, I'm coming up and then going through that point at the highest level and coming down. So then I trace my graph. And the moment I start repeating that behavior, when I realize, hey, I'm at the top of a peak again, and I'm about to go down. So now you realize behavior repeats here. So whatever behavior you notice was going on at the reference point, you track it until that behavior repeats. And then what you can do is you'll track the horizontal distance between when that happens. And you'll also notice here, what is that horizontal distance? Well, it's going to be right minus left, 5 pi over 2 minus pi over 2, which is going to give you 4 pi over 2, which is 2 pi. So again, you'll get the period 2 pi. No matter where you pick, you're going to get 2 pi. It's nice to pick the origin if you can reference the origin, because your left thing would be 0 for the origin. So you just pick the right point, the length of the right. But there's nothing that says you have to do that. So yeah, the period is just the horizontal length where the pattern starts repeating. And so given any particular graph, whenever the pattern starts repeating, that's what I'm going to pick. So I believe, let's see here. I go back to this one. Right, so notice here, it didn't actually touch the origin. But notice here, if I pick this as my reference point, then I start repeating the behavior once I hit here. What is that distance? Well, it's 2, because it's 2.5 is where it ended, and 0.5 is where that behavior starts. So I can look at this and I can know the period is 2. Now, in this question here, it asks about the amplitude, not the period, but I'm just using this as an example. Okay, so I can look at this graph and I can know that the period is 2, right? Because this behavior repeats.
Thank you. I get it.
So hopefully that's clear. Any other questions? So repeating again, all remaining homework is due on Wednesday. Final is on Monday at 9:30 a.m. 25 problems, 2 hours and 15 minutes, including upload time. I'll ask you to show your work for the majority of the problems. In terms of the question types, it'll be very similar to the question types on test 1 and test 2. So overall, the hope is, theoretically, I think it's possible and more likely that you would perform on average a little bit better than you would have performed on a regular test, because you're getting more time and more opportunities for partial credit. So yeah, like I said, I'm skewing everything so that you guys get the best grade possible. Yeah, without making it completely, totally unfair. Yeah. Any other questions while you guys have me here? I have a question for you guys. How has it been working in your groups? How often have you guys met with your groups? Hello? We talk sometimes. What does that mean? What is sometimes? How often is sometimes? Do you guys study together, do homework together? Just before a quiz or test usually? Okay. And during that time, do you study together? Okay. So in your group, you ask a quick question and someone in your group answers it. How do you know if they're correct? How do you guys decide on, yeah, this answer is the right answer? You don't know. You just trust your group member. Yeah, my group member tells me this is the answer. I just trust them wholeheartedly. No questions asked. So I guess parting word of advice. So I've told you guys all the things that I've noticed going on that I think actually hurts your performance and all that stuff. But one thing I would want to reiterate is if doing well at something is important to you, right? Doing well in this class might be important to you, might not be. No judgments either way. I understand that math isn't everyone's thing and some people just don't care. That's fine. However, if you do care and doing well at something is important to you, you do want to use every available resource to the best of your ability. And peers are a valuable resource. So these are things that I've noticed over the years. Sometimes students will be doing not so great in class, but they never decide to like go to tutoring unless I tell them go to tutoring, or they never decide to ask me a question unless I beg them to ask me a question, or and sometimes even then, like I beg people to ask me questions all the time, and I don't really get any questions, or you know when I force and put them into groups, they hardly talk to their group members. It's like there are all these resources that if you just use them, it makes your life so much easier, so less stressful, and it makes their performance so much better. But students just never use their resources. They think and some might have noble intentions. They might feel like, you know what, no, I should do this on my own. And, I don't want to ask for help and, other people carrying me. Well, I already mentioned in study hall how to ask for help and how to effectively use help to improve yourself. So yes, there is a danger of asking for help and not using it wisely and really not learning anything at the end of the day. That is a danger, but it's not a danger that makes it worth not trying. You do want to get help as much as possible. You do want to reach out to your peers, to your superiors, to people who have been on that road before you. And you want to do it as often as possible. Humans are social creatures. In general, the average person is going to learn better by having a conversation with someone than they would by just reading a book by themselves or just by practicing something by themselves. Or they would actually catch on faster to something. So I kind of set things up so you guys have all these resources, but it's not going to help if you don't take advantage of them. So really start taking advantage of your resources this week, especially this coming week. Really touch base with your group members, use the other resources, use Piazza, use your homework system, use your study tips, use my YouTube videos or my test solutions or whatever. Use all you can. That being said, I will end with a good luck. I'll see you guys next week. See you guys on the other side. Thank you for your attention. I know it's been a crazy year with how everything has been going and online classes and Rona and everything. But hopefully you guys are doing well and are healthy. And things aren't as bad as they could have been. And I wish you guys all the best in the future. And with that, we will end today's lecture. So you guys know how to reach out to me if you need to reach out to me. So we will stop there. Good luck. Have a good rest of the day. Have a good end of the semester. Good luck in all your classes. Hopefully you guys do well. And I'll see you guys in the next one. Ciao.